Alright guys, welcome to chapter 20. We're going to be learning about redox reactions, okay? And so you can see our little play on word, redox. And so we're going to be focusing in this section on recognizing and writing redox reactions. Alright, so let's go ahead and get started. Alright, so first we're going to recognize our redox or redox reactions. So with these reactions you have one reactant that is gaining an electron, and you can see the e to the negative superscript is how we would write electrons in these reactions. And then the other reactant is losing an electron. And so if there's a reactant gaining an electron and another reactant losing an electron, you know that you're dealing with a redox reaction. Okay? More often than not, our redox reactions are occurring in single replacement reactions. And so I've got two examples for you below. So you have copper chloride, and you see the charge of copper in this case is a +2, and chloride is a -1. Okay, and that's their charge, the charge of the atoms. Okay, not their overall charge like we've been doing before. And zinc has a 0 charge, and we'll get to some of the rules in just a little bit to explain why that's a 0. And then in the products, you have zinc now is a +2, copper stays, chloride stays -1, and because copper is by itself, it has a 0 charge. Let's look at the second example. Now you have copper oxide. You have a +2 and a -2, and then carbon is a 0. For the products of this reaction, copper then has a 0 since it's by itself, and in our carbon dioxide, you have carbon with a +4 charge and oxygen with a -2. Okay, and you can see that change where we went from a +2 -2 to a +4 -2. That's an example of a redox reaction taking place, and we would write those numbers as we would call them oxidation numbers, and we'll talk more about those in our rules. Alright, so let's look at some of the rules for assigning oxidation numbers. Alright, so on page 639 of your textbook, so the first page of 20.2, you have the rules for assigning oxidation numbers right there in your textbook for you. And so you'll also get a paper with these charges, with these rules, but write them down for better memorization. So let's start with elements in their neutral state. They're going to have a 0 for their oxidation number. They're not reacting with anything, so overall their charge is 0. So magnesium, when it's just one atom of magnesium, 0 charge. Nitrogen gas, 0 charge. Bromine, 0 charge. And so it's not really 0 charge, but 0 is their oxidation number. Monatomic ions have the same oxidation number as their charge. So potassium is a +1, hydrogen is a +1, fluorine, -1, chlorine, -1. Those are some easy ones. And so if it's a monatomic ion that has its charge, is going to have the same oxidation number. Oxygen usually has an oxidation number of -2. There are some cases where it can be -1 or even a positive, but those are more exceptions. Most of the time you're going to have an oxidation number of -2. Hydrogen, we said earlier, has an oxidation number of +1 in almost every compound. There are some exceptions to hydrogen as well, but for the most part, just like oxygen, remember this charge. Fluorine has an oxidation number of -1, and the sum of your oxidation numbers in a compound should equal to 0. And so we've got this example at the bottom of the page. Potassium chromate, the overall charge should be 0 because it's a compound. Alright, potassium, like we talked about earlier, has a charge of +1. Then you've got chromate having a charge of +6. And oxygen, because you've got 7 of those, you're going to have your 2 times 7. It should be a -14. All of those charges, so you've got 2 times 6 is 12. 2 times +1 is another +2, so you have +14. And the oxygens are -14, which leads to the overall charge of 0. Okay, so I know it's a bit confusing, but let's see if you can give me the answers to these next few. Okay, here are some examples. Alright, so the answers are already written for you, but let's just walk through it, and as you write them down, you'll have examples to look at later. So magnesium chloride. Magnesium is in group 2A, so it has a charge of +2. Chlorine is in group 7, so it has a charge of -1. Alright, the overall charge needs to equal 0. And so at this point it looks like we've got a +1, but if you look, chlorine, there's 2 chlorines. So overall you really are going to have a -2 overall charge, and so your +2, -2 will equal 0. But the oxidation number of chlorine is -1. Alright, let's look at the second one. You've got iron fluoride. Okay, iron we know has multiple charges because it's a transitional metal. Fluorine we know from our rules has a -1. So if we have a -1 oxidation number and we've got 3 fluorines, fluorine has an overall charge of -3. So to get a 0 oxidation number for our compound, we need to have a +3 for iron. So iron's oxidation number is +3. Alright, let's look at our last example. So calcium sulfate, you look at oxygen. Oxygen normally has a -2 charge, so we'll put that there. Calcium is in group 2A, so it has a +2 charge. So right now oxygen is -2 times 4, which is a -8, and calcium is a +2. So in order for us to get rid of that extra -6 charge that we've got, sulfur has to be the opposite charge. So sulfur is a +6. This is where it gets a little bit different from balancing equations. Alright, so now we have practiced and gone over the rules for recognizing oxidation numbers. So I want you guys to go ahead and practice this using the worksheet, Have You Seen a Redox? Okay, and hopefully you enjoy the play on words and you're able to complete this worksheet. Okay, do your best, complete all the problems. You can work in groups on this. Okay, if you need help, send me an email and I will try to get back to you at least over the weekend, like 23rd, 24th, okay, of April. Good luck. Alright, happy Friday, guys. Welcome back. This is the second part of our 20.1, 20.2 video. We are going to focus on writing our redox reactions and then also identifying reduction and oxidation reactions within our redox reactions. And so this is looking at our compounds and seeing which items are being oxidized, which are being reduced. And so in 20.1 you have some terms for those. You have which one is the reducing agent, or the substance that loses electrons, and which one is the oxidizing agent, or the one that accepts electrons. Okay, and so here we go in our first PowerPoint of that, or PowerPoint slide. So first you want to assign your oxidation numbers to each element in the reaction. Hopefully after our last class on Wednesday, you have gotten more comfortable with this, and when I get back on Monday, we will work on some of these together. So let's look. You've got copper chloride. Chloride is always -1, and you have 2 chlorides, so that's technically a -2 overall oxidation number, and we need to cancel that out, so copper has a +2 charge. Silver is by itself, so it has no oxidation number, or an oxidation number of 0. In our products, you have chloride equaling a -1, and we've only got 1 atom of silver, so in order to get an oxidation number of 0, it needs to be a +1. And then copper is by itself, and so it has an oxidation number of 0. So now we need to identify which element is being oxidized and which is being reduced. And so you can see I already have those highlighted under your problem for you, your equation. Copper chloride is being reduced, meaning that this is the one losing electrons, and then silver is our oxidized agent, meaning that it accepts electrons. So let's see how that looks. So you want to write the individual compound of the things being oxidized and reduced. Okay, if you look at copper, it goes from a +2 on your reactant side to a 0 on your product side. So, just like we said, it's being reduced, it is losing electrons, 2 of them. And you would write that on the reactant side. So you have copper +2 oxidation number plus 2 electrons yields your copper atom, and so that's going to have a 0 charge. So if you look at silver, you can see that this is being oxidized, that it is accepting electrons because it goes from a 0 oxidation number on your reactant side to a +1 charge on your product side. And so those you write down below. As you can see, your reduction reaction, you have your C, your copper +2 oxidation number plus your 2 electrons yields your copper atom, which has a 0 oxidation number. Then your oxidation reaction, you have silver, which starts with a 0, yields silver with a +1, and so you show that by that electron, that negative charge. And you can kind of look at these as math problems. You have copper, you have a +2, and then you have your -1 times 2 yields 0, because copper ends up having a 0 oxidation number on the product side. And then likewise with your oxidation reaction, silver goes from 0, 0 equals +1 plus -1. And so those cancel out and you get a 0 oxidation number. Alright, so let's go ahead and start continuing to write these. Make sure that the number of electrons for both reactions match up. If not, you need to multiply by the least common multiple so that they do. Okay, again, looking at that same problem, you have your reduction reaction. So you have copper has a +2, then you've got 2 electrons. Those 2, because it's losing 2 electrons, and so +2 subtract 2 negative equals 0. For our oxidation, okay, in the reduction part you have the +2 charges, you have those 2 electrons, and so we have to have 2 electrons in the oxidation reaction. So even though our charges are equal, we need to multiply that whole equation by 2 in order to have 2 electrons on your reactant side and 2 electrons on the product side. Okay, they're going to cancel out basically. So try this. That's where we're at now. You've got 2 waters plus calcium yields calcium hydroxide plus hydrogen gas. On our reactant side, we have water, so hydrogen in this compound has a +1 charge and oxygen has a -2. The overall charge will equal a 0 for that because you have 2 hydrogens. Calcium is by itself, so it is 0. And then looking at our product side, hydrogen is a +1, and then also as hydrogen gas, hydrogen is 0. And then our oxygen is -2, calcium is a +2. So if you do all of your math, you see that you're balanced with your oxidation numbers. And in this case, on our reactant side, hydrogen is reduced and calcium is oxidized. Okay, and so looking at those, you have 2 hydrogen atoms, and that's going to be 2 +1 charges. So you're going to need 2 electrons to cancel out those 2 +1 charges. In your oxidation reaction, you have calcium starting at 0, yielding calcium. You have a +2 charge, and then you cancel that out by 2 electrons. Okay, and so as you can see, the electrons match up. We don't have to do anything to make it nice and neat. It's already nice and neat for us. So that's what that no action required means. Alright, so that is all for this PowerPoint. I'm going to have you guys watch just one more PowerPoint. I'll walk you through some examples so that way you guys can work on the writing redox reactions in your group tables, okay? Or at least in groups of 3 to 4, no more. Please choose groups wisely. Pick someone who is going, again, to help you and not somebody who you are going to have to carry through the whole thing. Okay, it's okay to explain things, but choose wisely. If you are not understanding, send me an email and I'll get back to you this weekend because I will be back this evening. Alright, that's all. I hope you guys had fun learning about the red ox. Alright, I'll see you Monday. Bye.